So for those of you who are, here we go. Okay, so for those of you who are in the session now, I know that you can throw things in the chat. And if you've got questions, please put them there. But just by answering in the chat, how many of you are using QueryStore now? And what version or flavor of SQL Server are you running? Are you running on-prem, and are you using like SQL 2017, 2019? Are you already on 2022? Are you running in Azure? So while I go through the next couple slides and do the little introduction, I'd love to know what folks are using right now. This was one of the first times I think that I ever had a session where someone said, this is what I want you to talk about, which was kind of nice for a change, right? So I'm quite happy to talk about QueryStore Hints and how we can use them to stabilize query performance. But there's going to be some bonus content in here as well. But a little bit about me, as Dennis mentioned, I'm a program manager at Microsoft, but before I was a program manager, I was an MVP, and I was a consultant for over 9 years. And before that, I worked with SQL Server. So I've been using the technology for about 20 years. And when I'm presenting today, what I'm talking about today comes from my perspective as a user, not as a program manager. So don't worry about that today. If you want to follow up with me about anything, you can. My email address is here. It's an @Microsoft. But I'm not here today to so much say this is this feature and it's amazing and you should absolutely use it. I'm here to say this is this feature. I think it's amazing based on my work with it, with customers, and here's why I think you should use it, not because my company says you should. So I went through, I like to put the abstract in here, although I'm assuming that people have already read that and you're interested in QueryStore Hints. But if we're going to talk about hints, we actually have to go back a little bit and we have to talk about plan forcing also. So there's the bonus material in here, in that in order to really understand what's happening with QueryStore Hints, you also need to understand what's happening with plan forcing. So when I talk about we're going to understand how to stabilize performance without changing code, it's both of those options, which is, I think, one of the amazing values of QueryStore, right? Beyond the stuff that Dennis would have talked about with how do we find poorly performing queries and those that have regressed. Like, how then can we leverage QueryStore to stabilize performance when that occurs? So we are going to talk about plan forcing in here, which I know wasn't on the agenda. I promise we will talk about QueryStore Hints. I'm not going to talk about the IQP features. That was from another talk, and I know that there's a whole nother session on that, so we won't get into that. But we will talk about plan correction, automatic plan correction. So let me just see here what we have in the chat. We have a couple people. So 2014 to 2019. And then QueryStore is only modestly used. Okay. Main issue is lack of skills at our customer base. Understood. And then Steven says QueryStore with SQL Server 2019 on-prem. Okay. And this may have been covered earlier, but one recommendation I tend to make with QueryStore, whatever version you're running, right? It was introduced in 2016. We now have it all the way through 2022. It's available in Azure. It's in managed instance. Is that whatever flavor of on-prem you are running, that you run the latest cumulative update. As they discover edge cases or interesting scenarios with QueryStore and they make code changes, very often they port those code changes back to 2016, 2017, and now 2019. So I generally recommend that folks run the latest CU. Okay, so we have a range of SQL Server versions out there. Fundamentally, it's really tricky to configure your environment, even just an instance, right? One instance with maybe just one database, but I know a lot of you have lots and lots of instances that you manage with lots of databases on them. And it's very difficult to set up that environment, right? Things, not just MaxDop, that works well for every single query that you execute. It's really not just difficult, but I would argue it's impossible, because at this point, there is so many variations in queries that are being run against a database, and so much essentially that people are asking of the data in the database. And even though we have a lot of great options now related to data warehousing, and things like column store, et cetera, and you can move your data elsewhere, not everybody can and does do that. So very often you have one database which can become very large, which all these different queries are executing against. And you can't configure it just for one set. You have to try to make it work for everything. And what I find is that it's not uncommon for users to have tons of variability, tons of change in performance of a query. And there's two kinds of change that this is how I kind of classify it or categorize that change. And one of them is it's plan independent. So what I mean by that is you have this customer transaction info stored procedure that's running, and the duration might be 17 seconds, and then it's 2, and then it's 1.2, and it's 2 again, and it's 14, right? And this variability in performance isn't due to anything in the data. This could be due to blocking. This could be due to resource consumption. It could be due to resource semaphore waits because you're having issues with memory grants, right? This is where you're just seeing this variability in performance, but it's the same plan, and the data distribution is pretty much the same for these different executions. But for whatever reason, we have this all over the place, right? These differences in terms of performance. Whereas when something is more plan dependent, what we see when we look in QueryStore, for example, is that we have a query with 20, 30 different plans, and performance changes based upon what plan is selected. So, you can spend a lot of time, which you probably don't have, trying to tune and tweak your code and your schema and make small changes to your configuration to address every single query. But you don't have that time, quite frankly. And trying to do that in a production environment is dangerous, kind of scary, because if you're trying to make these changes live, you're putting the environment at risk, right? You may make one thing better, but you may make another thing worse. So this is where QueryStore really comes in to help. So before QueryStore, if we looked at how we would kind of manage those scenarios, if you had direct access to the code, you could ideally go and change the code in the schema to fix the issue. And I don't know about you, but that often didn't happen quickly. And I found that folks were often resistant to going back to existing code and making these deep changes to fix performance. I find that folks are very often focused on what's new, right? What are we adding that's new and shiny? And we don't want to go back and fix some of the older stuff. And so while this is what I consider the ideal scenario, what we want to have happen, it really doesn't happen as often as we would probably like. But fundamentally, when we have a performance issue, what I want to see is us addressing the problem in the code or in the schema. The very quick fix, which also does require direct code access, is that you put a recompile hint on there so that every time that query executes, it goes through optimization, compilation, and it gets a plan for that particular input value. And that's a quick win, but there are performance implications with that, right? All of a sudden now we've added CPU overhead and time to every query execution, which, depending on how frequently folks add this recompile hint to their queries, can really affect overall performance of the system. Now, if you don't have direct code access, which as database administrators, we don't, right? Or if we don't have a team that quickly moves to make changes, then we have to get creative. And we create these workarounds, which are not pretty, but they work. One of those is manually getting what I say, best plan into cache. And what I mean by that is that you have an agent job set up that every 5 minutes goes to see, is this particular plan in cache for a query? And if it is, I know that's a bad plan and I don't like that one. So I'm going to remove that plan from cache. And then I'm going to go ahead and run my stored procedure really quickly with a good value to get my best or my good plan into cache. And I've absolutely seen that as a solution, but it's not pretty. It's not elegant. I've also seen folks who will update statistics when performance is not going well. Statistics is another area of SQL Server that I love. And the challenge there is that very often, not always, but very often, that's just a Band-Aid to fix the issue. It doesn't really address the problem. And in addition to not truly addressing the problem, you've just introduced some overhead to the system while you go ahead and update statistics. So I tend to say that this is not something, sometimes I'll do this in red, right? No, we really don't want to try to update statistics to address a performance problem. There's valid scenarios, but most of the time, that's not where I go first when I'm troubleshooting. And then we have the things that happen outside of your code, and they happen without your application being aware of any changes. And plan guides are something that have been around for a very long time that you can use to kind of guide the optimizer into saying, this is what I want you to do. If you've ever used plan guides, you may have found them a little bit tricky to use. They're only using T-SQL to implement them. There's no UX to try to understand how to implement that. You have to rely simply on code. And I found that they were hard it was hard to understand if the plan guide was being used or if it failed, why. And so this is where we get plan forcing, which is, I think, an amazing tool, an amazing feature for data professionals to be able to use to manage performance temporarily. And let me pause for a second to really be clear. I think that plan forcing is great. I highly recommend it, but it is a temporary solution. Long term, what you really want to do is go and fix the code and the schema, because that is the best way to address the problem for the long term. So I think of plan forcing as the short-term solution, and then long term, you're going to go back and you're going to change the code, address the schema. And then also transparent to your application are QueryStore Hints. So QueryStore Hints essentially leverage some functionality that's there for plan forcing, which is why I feel like we need to talk about them together, because they're ways that you can manage performance without having to access the code, and they allow you to do that very, very quickly. All you need to do for forcing is to not all you need to do, but you have to have DB owner permission, right? So it's not that just anybody should be able to do this. You should know what you're doing, but it's very easy to turn on and turn off. And then there's also IQP features, which will be discussed later today, that are transparent to your application, which can absolutely help with managing performance and don't require any additional work by you either. So I'm going to hop over into my demo. And funny enough, and talking about Management Studio, this is a build of Management Studio that's not yet available. So we currently have Preview 3 of SSMS 19. This is preview 4. So hopefully you'll see that available to download soon. Okay. I have a copy of the Wide World Importers database, which I've already restored. And I'm going to start by enabling the QueryStore settings that I want. Now, I'm not sure how much Dennis talked about QueryStore settings in that initial session, but these options that I'm using here, these are not what I would recommend for a production database. This is just for demonstration purposes. So we've turned on QueryStore, and then because this is a demo database, I never know what is sitting in the QueryStore, and I'm just going to go ahead and clear all of that out. Again, this isn't something that I would typically run on a production environment because I don't want to remove all of my QueryStore data, but for my demo, it's fine. So we're going to create a procedure, which is called customer transaction info. And this procedure, we pass in a customer ID, and then we select back out that ID, and we do an aggregate of the amount excluding tax column. And we just do this for one given customer ID. So let's go ahead and create that procedure. And then I'm going to turn on my plan, or excuse me, my actual execution plan. So let's go ahead and do that. And you can see I'm running this with 2 different values. The first one is 860. The second one is 401. And if we flip over here to look at the plans, obviously these 2 plans have the same shape, right? You can see that we have this index seek here, and then a key lookup, and that goes into a nested loop. And so that shape is the same between those 2 executions because this plan was put into cache and then reused, which is a good thing. But you might notice that the line thickness here between these plans is just a tiny bit different. And in this database, it's not quite large enough to really dramatically make a difference in terms of the time. But if we come and we look at some of the information for the execution in statistics.io, you can see that for that first execution, that had about 486 reads, and it was about 60 milliseconds. And for that second one, we had 54,000 and about 151 milliseconds, so almost 3 times as long to execute. And if we then go back in here and we're going to clear the procedure cache entirely and then run the store procedure again, but this time just with the value of 401, you'll see that we get a different plan, right? Rather than that index seek with the key lookup, now we have a clustered index scan. And this is a very common classic problem that we see, and I've really simplified it, right? But this is a parameter sensitive problem. When I input a certain customer ID, it was 860, there's not a ton of rows that are returned, and so the optimizer says, okay, in this case, I'm just going to go do an index seek with the key lookup to bring back the data. When we execute it with a value of 401 and a cold cache, right, and no plan in cache, it says, well, there's a lot of values for 401, so I'm going to do a clustered index scan because that's more efficient for that much data. And if we look at the messages, right, you can see that the I/O here is actually less than when we did the index seek with the key lookup, and the time is 37 milliseconds. So for that data set, for that 401 customer ID, this makes much more sense and is faster almost. And if you look at the distribution of the customer ID, you can see that we definitely have what I call skew, right? We have 1 and 401 that have 26,000 entries. And then we have all these other customer IDs that have like just a few hundred. And I see this all the time in customer environments. There's usually one, if not many tables that have this great variation in the data in terms of how many rows there are for a particular value, right? So we call that skew, or a very randomly distributed set of values within that column. And this can lead to big changes in query performance and in plans for a given query. And you'll notice if I look at this plan, I have a warning here, a missing index notification, right? There's an index that I could create that would address this problem. If we open that up in a new window, right, you can see it's a non-clustered index that leads on that customer ID. That's our predicate. And then includes that amount excluding tax because we were aggregating on that, right? And that doesn't need to be in the key column. It's listed as an included column. And so this index makes a lot of sense. And if this were a procedure that we were running, not just thousands of times a day, but thousands of times an hour, it really makes sense to add that index. But what if this is a third-party application and you don't have the ability to make those kinds of changes, right? Sometimes those aren't permitted. You could violate your maintenance agreement or your agreement with the company if you do that. You could add this optimize for hint to the query, but again, that requires code access. And if this is a third-party application, you don't have that. Or if your company is not really speedy when it comes to making changes that you need, and this is a problem, that isn't going to work for you, right? You need something that's going to fix performance now. So if we come into, let me refresh all of these here. So if we come into our Wide World Importers database and we look at the QueryStore folder and we go into our top resource consuming queries, we can see, right? And I tend to change this default view. I like to look at this in a grid format because I like to easily see the text of the query here. If I go back to the graph, right, I have to hover over that in order to see the query text. And sometimes I'm really lazy and I really just want to see it in this view. So when we look at this stored procedure, if you look over here on the right, you can see that we have two different plans. We have plan ID 3, which is this one up here, the blue dot, and plan ID 4 down here at the bottom. And plan ID 4, which is the plan that's selected right now, this is our clustered index scan. And plan ID 3 is that index seek with the key lookup. And I showed you a screenshot several slides ago that had 20 or 30 different plans. It's not as exciting in my demo environment, but I've absolutely gone into environments where for a given query, even a given set of queries, we see 20, 30, 50 different plans for that query over time. That is not uncommon. So when that occurs, right, when we're in the situation where we have multiple plans for a query, what can we do with that within QueryStore? And you can also see this within the T-SQL. So I want to take a moment, right? The UI, actually, let me step back even further. What I love about QueryStore is that it works. It's available, it's accessible, it's usable for folks, whether they're new to SQL Server or they've been working with it for a long time, right? This UI will help you, these reports will help you dig into the data and understand what's going on. But they're in system tables in the user database and they're exposed through system views. So you can go in there and you can write queries and you can see exactly what exists, right, by looking at the data itself. So we can see down here that we have two different plan IDs and we have the plan over here, and I can go ahead and click on that and it will open the plan. So whatever you're comfortable with, you can do here if you're more comfortable with the T-SQL. So if we say, okay, We have this stored procedure that's being executed thousands of times an hour. And as long as it's executing with the index seek with the key lookup, we're good. But every so often it switches over to the clustered index scan, and that's not good. And the thing is we would typically think that, but if you look at the duration here, right, the duration for the clustered index scan is actually less. So intuitively, right, based on our history of working with code, we might think that we shouldn't scan the clustered index. That's really bad. But in this case, the table's not that large, and maybe that's a more efficient way. Or in a production environment that has millions and millions of rows of data, the index seek with the key lookup may be what you prefer. But let's say for today, we prefer the clustered index scan. If we want SQL Server to use this plan every time the query executes, all we have to do is click on this force plan button. So it's over here on the right, and it gives you a little pop-up that says, okay, you want to force query 3 to try to use plan 4. Notice that it says try to use there. We want it to use plan 4. And so to do that, all you do is you click the force plan button, and it pops up a validation. You want to force plan 4 for query 3. We say yes. And then you'll notice here that if we zoom in a little bit, right, that plan 4 now shows a checkbox. So when we have a plan that is forced, it will have a check on it when we look in this view. So now if we go back, and you can also do this with T-SQL, which I would actually recommend. And the reason that I would recommend that is because you can put this into change control and you can track that this has been forced. Otherwise, you're not going to have that history. We don't write anything to the error log when you force a plan. There's extended events, another one of my favorites, that you can use to monitor that. But honestly, a lot of folks won't have that. So in general, I would recommend that you use the T-SQL. And let's see, we forced plan 4, right? Or excuse me, we forced for query 3, we forced plan 4. So this would be the stored procedure that you would run to do that. So now that we've done that, let's see what happens if we rerun this. And you can see that it's using the clustered index scan. And you may think, hold on a second, you ran it with a value of 401 last. Like, how do I know it's not just cached? Well, let me go back. Let me get rid of everything from the plan cache. And then let me go rerun these again. And so now we can see, yes, we're doing the clustered index scan. Now, how do I know that this is the forced plan? Well, there's two things that you could do. The first one, which is probably what you'll do most often, is you'll come back in here and you'll refresh this view. And you can see now that we have that plan 4. We've got another dot with it that has a check mark. So I can see that the forced plan is being used. And if we continue to run this stored procedure over and over again over the course of time, right, you would continue to see that yellow dot with the check mark on it, indicating that that's the plan that is being used. If you actually go in and run the query with the actual plan, like we're doing here, and you go into the properties of this, and you go to the select operator, what you will see, if you zoom in here, is you will see, why can't I see? Oh, here we go. My eyes are not quite awake yet. You have this use plan true. So basically, what is happening behind the scenes is we have told the optimizer, this is the plan that we like. And the optimizer is basically kind of doing, it's basically saying when it executes the query, this is the plan that I want you to use. And that's basically called use plan functionality within the engine. And so if you see use plan is true, then that is the forced plan that is being used. If I want to take forcing off, all I have to do is select Unforce plan here. Or I could use the T-SQL to do it. So the moment that I say Unforce, it says, do you want to do this? Yes. And then all those checkboxes go away. And so then the query is going to go through normal compilation and optimization, just like it would before. So I'm going to pause and see. I don't see that there's any questions in the chat, but I'm going to take a sip of water. And if there's any questions about forcing, let me know. Otherwise, we're going to move on. Okay. Move on. Sounds good. Okay. So here's the thing about forcing. You can find queries with multiple plans and force one of them. It is not schema bound, which means that if you make some kind of a change, it will and it can't force your plan, then forcing will fail, but your query will still run. It will still go through normal compilation and optimization. I do recommend that you use extended events to monitor your plan forcing. And understand that if you forced a plan and it is no longer likely the best plan, QueryStore is going to continue to use it. There is no process in there with manual plan forcing where the optimizer goes, oh, I see that you have this plan that's forced, but there's actually a better plan and we should use that instead. There's no logic in there. So you have to, again, pay attention to what's going on with plan forcing. Because it's not just a set it and forget it. Your database is a living, breathing entity, and the data in it changes, right? The data changes probably far more frequently than your code changes. So you need to think of forcing as a temporary option and as something that you need to monitor and pay attention to, because what plan is best today may not be the best plan in a month or 3 months or 6 months. And if you think that you can just force it and then not worry about it anymore, I don't think that that's a good approach long term. There's some typical reasons that I see forcing fail. It's because somebody might have dropped an index and the forced plan used that index, and so now it can't use it anymore. People change index names. I don't find that happens a lot, but that's absolutely a reason that this can fail. Or they remove columns from an index, or they change the order of the columns around, especially the key columns. And the last one is a big one. If you modify your procedures by doing a drop and create instead of using an alter procedure, your object ID changes. And what you may or may not have noticed when we were looking at the QueryStore data, if we come back over here and I run this query, we have the object ID right here. So the query is tied to the object ID. And if you drop and create the procedure and the object ID changes, then that association is lost. And so plan forcing will all of a sudden no longer be in effect. That's a challenge that I see very, very frequently with folks. It may not always be obvious that you have a plan that's forced. So you need to look at the actual plan. You need to look in QueryStore to confirm. If you've got multiple environments, if you have a test, a dev, a QA environment, you know that performance can be very different across those environments. Plan forcing adds another reason that performance can be very different. So you need to check to see if you have forced plans. And then when you're making changes to your code and your schema, be aware of, do I have any forced plans that are using any of these objects that I am modifying, because that could create a problem. Up until SQL Server 2022, you could not force a plan on a replica by forcing it on the primary. So there is plan forcing on replicas available with SQL Server 2022. It will be available. If you have, this is a very tricky one for any of you that have availability groups. If you have your primary and you have a plan that is forced and then everything fails over to one of the replicas. You should expect that plan forcing will be there on the replica unless the database IDs between the primary and the replica are not the same. It's a really interesting scenario that I've had customers run into, but it's something that you have to think about, unfortunately, when you're seeding the availability groups to make sure that the database IDs match. But you should expect in general that when you fail over, the plan should remain forced. But if you find that it's not, then go check the database IDs. And you can't force a plan for a query if that query didn't actually generate the plan. So I've seen folks say, I have a really similar stored procedure with a query in it, and it has the plan that I want. Can I take that plan from this and force it over here for this? And the answer is no. It won't let you do that. It'll throw an error. If you turn off QueryStore, then you have no plan forcing. All the data will be there, but you can't, it won't work. So you have to have QueryStore turned on. And to me, QueryStore is something that you turn on and you leave on. It's not turn it on, turn it off, turn it on, turn it off, like leave it on. And forced plans do not get aged out. So as long as you have a plan that is forced, if you've got the your QueryStore configured correctly, it should age out data after a certain amount of time. Forced plans will not be aged out. Now let's talk about QueryStore Hints, which was the reason for this whole session, but I had to kind of build up to do a little bit of background here. So for QueryStore Hints, this demo, sorry, let me scroll up to the top here. This demo, I'm actually going to run against my Azure SQL database, but it will work also against SQL Server 2022. This was a feature that was Azure first and then came to the next box release. So I think that I'm connected to this, and let me make sure that I can clear out anything in that QueryStore. I already have QueryStore enabled for that database. And this procedure that we had used previously in my other demo, we're going to use that here as well. Let me just make sure that I have the right database selected. There we go. So exact same procedure that we had before, right? We pass in a customer ID, and then we display out that ID along with the aggregate of the sum excluding tax. And let's also turn on our actual plan. And then these are the same two input parameters that we had before, right? We ran with an 860 and with 401. And if we look again, we have the same plan that we had before with our index seek and our key lookup. But notice here that there's something that's a little bit different, right? And that we have a little bit higher impact here in terms of IO. We go from 10,000 reads up to 1.7 million when we use that value of 401. And just so that you can see, it's pretty much the same here. If I rerun this with the value of 401, we'll get that clustered index scan, but there's more reads that happen in this database, 25,000, than in the on-prem database I had that was less than 2,000. And so just to confirm here, right, that we have this distribution of data similar, but it's magnified, right? In the other database, we had about 20,000 for customer ID of 1 and 401, and here we have 500,000. So it's basically the same data set, but I've blown it up to try to demonstrate how problematic this really can be. Now, if we open up within our Azure database here, right, we have QueryStore in here, and I can go into top resource consuming queries. And this is going to look like exactly what we saw before, right? Plan IDs are a little bit different, but we can see we have our index seek with the key lookup, and we can see that we have our clustered index scan. But what if we don't want to force a plan? What if forcing the clustered index scan in the Azure environment is a very bad idea, because here we're paying for performance, right? We're paying for how much CPU we use, right? Or DTUs. And so I don't want to have a clustered index scan if I don't really need it. But at the same time, this index seek with the key lookup, this is not a good option when I use a value of 1 or 401. And so I don't want to force a plan here, because then I feel like I'm stuck and I'm using more resources than I need to, and I'm paying for that, right? Technically, you pay for it on-prem, but you don't see those dollars in the same way, and you already have the server, and so technically it's paid for. But here, right, it's a lot more live, right? There's a lot more immediate consequence. So we might say, I don't want to force the plan. What I want to do instead is I actually do want to recompile every time it executes. So in order to do that, we need to know what the query ID is. So let's come back over here to our top resource consuming queries. Here is this query in question, and that is query ID 2. Okay, so for query ID 2, what we're gonna do is we're gonna say, we're gonna run this procedure, SP QueryStore set hints. And for query ID 2, this is the hint that we want to apply. We want to put an option recompile on there. So if I go ahead and run that, good to go. I don't need to clear the cache, right? If you remember, the last execution that we had was for a value of 401. So in the plan cache, there is the clustered index scan plan. We'll run both of these together. And when we look at the plan now, you can see that we have 2 different plans appropriate for each value. For the 860, we get the index seek with the key lookup, right? That right here. That's our 860. Let's see if I can. Great. Bottom plan here, our clustered index scan, is for our 401 value. So each time those ran, it basically went through compilation and optimization. Now, what's interesting here is that if you look at the query, which I'm going to highlight here in blue, you can see this query looks exactly the same. Nowhere in this text do you see anything that says option recompile. That's really important to understand, right? The long-term solution here would be to create the non-clustered index, but the recompile hint is a good short-term solution here. Let me show you another scenario. Let's say that we have this query. This is a little bit more complicated query, right? Against orders and ordered lines, still using a customer ID, and then doing an aggregate. So let me run this one. This might take a little bit. This is a very small Azure SQL database that is not well resourced. I think it's just on a basic tier. But when this one runs, once it completes, we're going to go find that within our top resource consuming queries. And sometimes we can see it show up in here. Let me see if I can find it this way. There we go. So now this is finished. Okay, so let me refresh this. Okay, so here is that particular query, which is our select against orders and order lines. And you can see that this is an index seek with a key lookup, or sorry, 2 index seeks into a nested loop. So we have 2 different tables here. So it's seeking a non-clustered index and then another non-clustered index, which is also a foreign key. But what if for some reason we decided that we really don't like the nested loop, we really want it to have a hash join? We can do that, right? We can make crazy decisions with QueryStore hints just like we can with regular hints. So here we have query ID 13. So we'll come in here and we will say query ID 13, and then we'll go ahead and execute this. And then we're going to rerun this. Now, it runs a little bit faster. And if we look at the plan, very different plan, right? First of all, what I notice is that we have parallelism in place. So we have all the parallel operators, but for sure, we have right here in the middle, right? We have our hash match. And if we go back to our top resource consuming queries and we refresh this and we look at this query, right now we can see that we have a plan count of 2. This is one of my favorite columns as an aside in this report. And we can see that we have plan ID 17 and we have our original plan 14. But again, what's tricky is that we don't see in this view that there's a hint applied. In order to understand that, you have to use this QueryStore Hints view. So this view is pretty important. It gives us the hint ID, and then it ties that to the query ID, and then it tells us what the text for that hint is. And then if there's any failures, it has that listed as well. So in order to understand what queries have a hint applied, you need to run a query like this. And we're going to change this so that we specifically say which query IDs we're interested in. But this is kind of similar to one that I ran before. The only difference here is that it joins over to the QueryStore Query Hints view. So when we do this, now we can see, okay, here's what the query hint is, here's what the text is, and here are the plans that exist. But what's still tricky about this, that I want to make sure folks understand if you're going to use it, is that this doesn't tell you, it doesn't concatenate the text for you, right? And it's possible that you could have a plan in here from before you applied the hint, but you wouldn't be able to see, you wouldn't know that for sure. It's because the way that we're joining and the way that information is tracked, it doesn't say that this plan was generated with this hint applied. So it's tricky. One of the things that's tricky is that it will override an existing hint without warning. So let me show you what I mean here. I can do this with this. I haven't even run the query. And if I come back in here and run this again, right, this query hint text has changed. But technically, these plans weren't generated with this hint. Now, we could run the query with this hint and we could get those same plans, and we likely would. But it's a little bit misleading when we run this query to see what hint exists for the query and what plans exist. So that's something that can be very difficult when troubleshooting, because again, there's nothing that says there's no error logging that's enabled by default that says someone went and applied this hint to the query at this time. So if you have multiple folks who are in your database who have this power, you could potentially be stepping over each other or making changes. And if you're not communicating or if you're not using change control, you might not understand what happened in what order. So that's something to be aware of when using this. But what I love is that it gives you the ability to quickly address a problem without waiting for a developer or an engineer to make the code change or someone to approve it. It's extremely powerful, almost dangerously so, but in that it allows you to manage performance in that way. It does check syntax, right? If I have a typo in here, I have query option recompiled, not recompile. It will throw an error, right? And it will tell me that that syntax is wrong. It also doesn't support every single option yet. So if we try to run this with an optimize for, that hint is not currently supported. So there is documentation that lists what hints are supported. So as more hints are added, that documentation will change. So I'm going to pause and see if anybody has questions specific to hints. If not, I've got 10 more minutes to talk about automatic plan correction. But as this was kind of the focus, I want to make sure that if there's any questions, I answer them. I never thought I would be this thirsty this early. So so there's a question, which is it possible to authorize these hints? I don't quite know what you mean, even with your comparison to GitHub. What do you mean by authorize? In order to, you know what? That's a really good question. This is a really good question that I don't know the answer to off the top of my head. So hold on one second. Let's double check. I think I know what it is, but I want to make sure I know what the permissions are. There's all the best practices. I am pretty confident that in order to do QueryStore hints, in order to be the person who applies them using, right, this kind of code, you have to have DB owner permission. So in terms of authorizing folks, they have to have that permission in order to make that change. And it's funny because in the documentation, even I'll just drag this over. Someone had said, right, we recommend it as a last resort for experienced developers, administrators. Now, if you want to audit this, if you want to track what's happened, then you want to use extended events for that. So within extended events, if we come in here, and we go to events, and we go to hint here. So we should have
I mentioned before his small joke about how old profiler he is. That joke on Twitter. I mentioned to the attendee.
About how old Profiler is? Oh, from 1998, that it's 24? Right. Very old. So let's see. We should have hint load started, lookup failed, hint unloaded, admin delete event. That's not what I want at all. That's stretch. Use hint enabled. I'm going to just go off script for a second. Let's see what happens here. Hint diagnostics. I don't think that's going to be what we want either. Okay, let's see what happens if we do this. So we'll, oh shoot, this is on 2022. I should be able to still do this anyway. Hold on. Was there a hint succeeded? I don't think there was. This is a really good question that I think what you're saying is how do I monitor when someone applies a QueryStore hint? And I don't have the code set up for that. And while it would be fun to dig through that, I don't know how quickly I can find that answer. So my request would be send me a follow-up email so that I can confirm how we need to do that. Because we should have, is it related to change management? No. I mean, you should have change management in place that helps you track this. That would be my recommendation. But I think what we would really want is we would want a way within SQL Server to know that somebody went and applied a hint to a query, right? So change management is an external system where you're going to have to go and do something. You're going to rely on somebody to do something. If you have that in place and it works well, then use that. But otherwise, you're going to have to fall back on something like extended events to help you track when that occurs. So I need to understand and confirm how you would do that. I don't know off the top of my head. It's a good question. Okay. Let me hop back to the slides here. So again, QueryStore hints give us the ability to add a statement hint onto a query. And you don't have to have direct code access in order to do it, but you do have to have QueryStore enabled. So it has to be turned on in order to use QueryStore hints. And it says currently available over in Azure SQL. That is incorrect, right? It's also available in SQL 2022. I just did my demo in Azure SQL, but it's also part of the 2022 release. And Steven says, query the plan cache, read the XML plans, and I think there's a property that says what hint was used. Well, now I'm curious. Let's see here. If I take this query, hold on. I have a query that goes to the plan cache. Now I'm really curious. And since that was the whole point of this session, I'm not going to be upset if I don't have time to talk about automatic plan correction. So let me take this. Let's go over to this demo. And let's see what we have in the plan cache. Here's the plan. Ha! I learned something new today. Here we go. So it is in the XML. So we can see it there, but that's not going to tell us who did it and when. That's the only bad thing. So now I'm going to try something. Oh, I have all kinds of things that I would want to think about. So it's here within the plan. We could see that not just in the plan cache, Stephen, but we could also see that within QueryStore. We should be able to. I do want to double check this. Hold on. So let me come back to QueryStore hints. Let me come in here. Let me refresh these. Here it is. Nope, I can do it from here. Properties. It is in here. So it exists in the plan that's in the plan cache, but it also exists here within the plan that's stored in QueryStore. So you can parse the XML, not just in the plan cache, because that's transitory, right? But you could parse the plan cache here within QueryStore to find what hint was used. Now, here's my final test. If you remember, I went in and I changed this one to an optimize for unknown, right? So now let me go back and re-execute this a couple times with optimize for unknown. And then I'm going to go back to my top resource consuming queries, and I'm going to refresh for here. Let me refresh here, right? So this executed again just now. And if I come in here and I look at the properties and I go to the select here, why doesn't it have that same information that we just looked at? Let me make sure. Let me come back in here. Let me go top resource consuming queries. Right, I reran the procedure. Here it is. Here is this. But right now, I don't see this in here. And it was before. So I'm a little bit confused about what happened there. And I need to play with that. So I learned something new. Thank you. And the big question is, right, which hint was used for the query? How can I definitively see that? And that's something that I need to investigate and figure out in a little bit more detail. It should be in the plan, but what I'm looking at right here is inconsistent with what I was seeing before. So I need to figure out maybe how I broke this or what I did differently. Okay. I have a couple slides related to automatic plan correction. I'm 2 minutes over. So I'm going to talk through those really quick. I'm not going to do my demo, but I'm just going to talk about automatic plan correction. Dennis, unless you want me to stop.
Erin, after your session is our lunch break, so don't mind about the time. You can go ahead.
Okay, but I want to make sure people have lunch. So I'll talk through this part, okay? I just won't rush, but I will talk through it. So in addition to being able to manually force plans, you can also let SQL Server do that for you. So if it detects that there is a regression, if it detects that it had a plan and then the plan changed for some reason, and the plan that comes in after that is worse, what will happen is it can automatically go back and it can force the last good plan. This is turned off by default for an on-prem database. Here's the T-SQL to turn that on. And you can use the information that appears in this DMDB tuning recommendations to make plan forcing, to implement manual plan forcing yourself. But what's kind of a kicker here is that this is only an enterprise edition. So this is in 2017 on-prem, enterprise, and higher, and then also an Azure SQL Database. So in Azure, if you didn't know, you do have enterprise edition. So it's available there. And here's the way that it works. If we start at the top, right? So let's say that we had a query that was executing with the plan, and we had, for some reason, a plan change, and we get a new plan, right? We have a current plan. It's going to compare the current plan's performance to the previous plan's performance. And it's going to look to say, okay, is there a regression in performance? Did the plan performance get worse? And if it did, then I want you to go force the last good plan. So if the previous plan was better, go force that one. And then after you force that, monitor to make sure that that plan is still good. And as long as it is, keep using it. However, if it regresses, if there is a recompile, like say because of a stats update, or if forcing fails, then go and unforce this. So this is a continual feedback loop, right? That's built in, which is really powerful. And so it's kind of scary to some folks, right? This is the question that I get a lot, right? Can I trust this? And it's code that's written by humans, so it's not perfect, right? There's no perfect code. But the thresholds that it uses both for did something regress and do we need to back off, right? Do we need to unforce? They were developed with telemetry from Azure SQL Database. The amount of telemetry that exists is mind-blowing. And so it used that telemetry to determine what those thresholds are. And it may not catch every regression that you expect, and it could make a not so great decision, but it has logic built in to recover from that, which is reliable, very reliable. And there's continuous validation of this built in. So I've had people say, like, should I really enable this? And if you're running enterprise or if you're running Azure SQL, then yeah, I think you should. It's designed to help make your life easier. It's not designed to take away your job, right? You probably have way too much to do. And this is something that can help you manage plan performance so that you don't get the phone call in the middle of the night or on the weekend to say, hey, all of a sudden performance has gone south. What the heck is going on? Can you come look at it? So automatic plan correction, I've seen one scenario where it was problematic. And that was what I would consider a very, very edge case scenario. And they were able to make some other changes where it then made it possible for them to use that. So in general, and a lot of the majority of the databases in Azure are using automatic plan correction without issue. So I think it's a really good feature. So in terms of how you can leverage QueryStore to manage your query performance, very simply, you can see which queries have multiple plans, and you can see when you have regressions, right? You can then go determine what you think is the best plan to use. You can temporarily force that plan or apply a hint, right? Either one of those, you have two options. And then behind the scenes, work with your developers to change the code or the schema. Automatically, you have automatic plan correction, and then you have some of the IQP features that are coming in later sessions. So the key, which I'm sure that has already been pointed out, is that all of this relies on QueryStore, right? It is this fantastic feature. I think one of the best features that SQL Server's introduced in years, that we are going to continue to build upon, as is evident by what we're doing with IQP. So if you're not using QueryStore, I would really encourage you to start to take advantage of these improvements that you can make for performance, both manually and automatically. So with that, I will pause. Any other questions? I think my last slide is my thank you slide. Yeah, there we go. Expand the oh, okay. We want to figure this out. I don't disagree with you. Expand the optimizer stats usage. Now, if I go back to here and here, right? We all saw it, right? There's a recording that says we saw this. I don't know why I can't see it right now. I'm gonna change this back. Let me do this. Let me do this. Let me look at the plan cache. Open the plan. Right, so here it is. So now I'm not crazy. We can see this. This is the plan from cache. So now here's QueryStore. Let me refresh QueryStore. Here's this. Which plan was that? Clustered index scan right here. It's not in there. It is there. Why am I not seeing it? I have this. Actually, let me do this. See, here's my challenge. Here's the plan from cache. It's not expanded, right? It's right here. But when I come over to this plan over here, it's not there. So that makes me think that it is not in the plan that gets stored in QueryStore. Which is a little bit interesting. But okay. I think that I got to figure out how I can write a blog post, which is funny because I don't have my own blog anymore. So I have to figure out where I can put it. All right.